Hello everybody! Thanks for joining me for the next video in a series of videos for our Antibody ID Week procedures surrounding our new SOPs. This video is going to be talking about cold reactive antibodies, so I'm going to pull up that procedure. But first I want to kind of tell you how you're going to get to that procedure. There are two different ways. So you could be going through the Antibody ID Guide SOP, and you might have an antibody with a positive autocontrol, and then perhaps your monospecific anti-C3 DAT is positive. If most or all of your cells are positive with similar strengths and reactivities, you may suspect a cold antibody, and that's how you'll end up in this procedure. Also, you may end up in this procedure if perhaps your autocontrol is negative, but then you go to rule in or out an antibody to a high incidence antigen, and you realize that you might have a cold antibody on your hands. So perhaps your reactions are weaker mixed field and gel. They could be strong though. They maybe react in immediate spin and tube methods. Maybe your gel cross matches are positive, and maybe your tube cross matches are positive to the same extent as your positive tube screen. So there are different ways to kind of rule in or rule out other antibodies. And I go through those in the Antibody ID SOP, and then I do direct you to this cold reactive antibody workup SOP when it seems to fit. So just a little bit of background. Cold antibodies are most often IgM antibodies that cause unexpected reactions in the reverse grouping with your ABO blood typing or in your routine antibody screening methods. And so benign cold antibodies can be found in healthy individuals, but they don't often react at 37 degrees or body temperature in those cases. However, some pathological cold autoantibodies might be detected at 37 or Hg, and those are usually secondary to other diseases. So for example, in an infection with Mycoplasma pneumoniae, you might see anti-big I, or anti-little I is known to be associated with infectious mono, or anti-big P is associated with paroxysmal cold hemoglobinuria. So these are kind of the catchphrases and the good terms to know when you're thinking about cold antibodies, especially if you're checking the patient's charge or you're looking at history and you see, oh, positive blood culture for this or that. And then that can kind of help you see that you might have a cold antibody. All right, and so the purpose of this procedure also is not to only specify or try to specify or know that there's a cold antibody here, but also to make sure that we identify any underlying or masked alloantibodies, because we want to make sure that we are able to provide safe blood products for patients. If we can't see underneath, then that becomes a scary situation. So that's the point of this procedure. If we're unable to specify or see underneath those cold autoantibodies or cold antibodies, we can center across for adsorptions, and I will talk about that once we get there. So the first part of the procedure talks about, when the antibody panel is pan-reactive, etc., what your typical cold antibody reactions will look like, what you should do next. And essentially the next thing you want to do is move to perform a list screen and autocontrol per our standard operating procedures. And the idea is that we're going to be looking at these reactions at immediate spin, 37, and Hg phases to give us clues about what antibodies are present and kind of how strongly they're reacting. And so if your list screen or your parallel screen is negative, then you've ruled out cold antibodies. Because you would, the antibodies that we're looking for, you would detect those at immediate spin. And so if you are found in this situation, you might be in the wrong procedure, and I urge you to go back to the Antibody ID Guide or consult with a technical specialist or lead to see if you can back up and go to the Antibody ID Guide and look at that evaluating reaction strengths and pattern section of the procedure. If your screen is positive, you're looking for reactivity at immediate spin, at least for cold antibodies. And so they're varying extents to which cold antibodies can be seen immediate spin through Hg. Sometimes weak antibodies or weak cold antibodies you'll see only at immediate spin. Sometimes more clinically significant antibodies or cold antibodies could be seen at immediate spin 37 and AHD. I hear my dog. And so essentially you're going to want to look at this and see what you've got going on. In both cases, you're going to want to perform a room temperature 4 degrees screen or panel to determine what kind of specificity you have. And also, depending on if your antibody reacts at AHG or not, that's also going to tell you if you're going to need to try to pre-warm away the antibody so you can see clinically significant antibodies underneath that react at AHG, or if you can move forward. And so then I go on to talk about performing that cold screen and just essentially follow the room temp 4 degree panel procedure. But I do go into describing the result interpretation in this procedure for ease. So I talk about if all 3 screening cells are positive and your O cord cells are negative and your A1 and 2 cells are positive. That's an anti-big I. So keep in mind why you're using all these different reagents. Obviously, you need screening cells to kind of help you specify if there's an alloantibody, say an anti-M or an anti-P. Also keep in mind that they are blood type O. So that can matter too when you're looking at cold antibodies that might have that H antigen specificity. If the patient is A or A2 positive, you want to include cells that are A1 and A2 positive because essentially A1 cells are A2 cells. Because essentially you want to look at the varying antigen expression that's on those cells based on whatever reactivity you observe. So if you think about an A2 cell, not all of those A antigens are converted to the A1 antigen, and so there's more H antigen present. That can give you clues. Or if you've got a weaker reaction with the A1 cells, maybe it's related to H. Remember that these A2 and A1 cells and your screening cells are all big I positive. So big people, big I, they're adult cells, adult donors. That's going to give you clues if you've got the same reactivity with different antigens. So A2 and A1 cells reacting the same. The other cell that you're going to add is an O cord cell. So that's going to help you because O or cord cells lack the big I antigen and actually are little I. So little people, little I. They also are O's, so that's going to show you it's going to be showing you the H antigen expression is present. So you really want to think through situations like, here's my strength of reactivity, what's physically on these cells. And keep in mind for cord cells too, they have other antigens besides little I and O. They have other antigens that could be possible. So you can always refer to the technical manual if you're feeling like you might have an alloantibody here. But otherwise, I've got it well planned out here in words. And then I also know people are visual. And so I have it here in a flowchart for you if that's more helpful. I do have an asterisk though here, and I say this, I put a little, caution here. If none of the above scenarios match your test results, so if nothing that I've written out matches your reaction patterns specifically, that's okay. Spontaneous agglutination may occur when testing at cold temperatures. So you stick some patient sample and plasma in patient plasma and reagent red cells in the fridge. If it gets cold enough, sometimes there's some spontaneous agglutination that takes place at 4 degrees. And so you may just have to report your antibody as a cold antibody. And that's okay too. It happens. Antibodies can't read, so they do whatever they want. And even the tech manual shows plus or minus in their chart when describing different specificities, basically saying anything can happen. And that's what makes this fun. And so moving on, the next section refers to screening and compatibility testing methods. So essentially, however way that you were able to identify your antibody in the screening method may be what you need to do for compatibility testing. But there's one caveat. So if your cold antibody is reacting in gel, then move to our least sensitive method for compatibility testing, which is LIS for future screens and cross matches. If your cold antibody is not reacting in LIS AHG, then that's going to be the primary cross match method. If your cold antibody is reacting in LIS AHG, you want to try pre-warming your plasma and red cells. So you're going to be doing a pre-warm screen and potentially a pre-warm cross match if it works. Pre-warming please go and refresh yourself on that procedure. I think people think they know what's in there, but I found some variation when reviewing the antibody ID workups. So make sure you know how long you're going to be incubating for. Some benign cold antibodies can be incubated for 30 minutes and kind of go away. Sometimes more significant ones take 60 minutes to disperse, so you might have to do some trial and error until you know. If pre-warming does not work, then we would need to send the specimen to the reference lab to Red Cross for adsorptions and an antibody workup, because we need to make sure we know what's underneath that antibody, any allo antibodies. And so again, I have that written out for you in a flow chart, so I hope that helps. It's nice to see it kind of with little arrows and boxes to organize your thoughts. And then that's pretty much it. The last section goes over results and how to enter things into the computer, how to enter proper ABI and BBC, etc., and BBCMC. I've given some real life examples, making sure you enter your repeat antibody screen and enhancement codes. And and then I also have included in this procedure how to make sure your result compatibility testing, if we should do it in-house or if Red Cross is doing it with absorbed serum or plasma. So I hope that helps. I know for the longest time, a lot of you had the cold antibody ID PowerPoint presentation that I had made like 2 or 3 years ago. And that was kind of my first stab at this. And this procedure is developed from that and has evolved a little bit. If it can be enhanced at all, please let me know. And I think it's a good jumping off point. So cheers.